Good morning. Today we're going to cover Unit 5, Lesson 7, Negative Rates. Today's learning goals: let's apply what we know about sign numbers. You are watching the lesson walkthrough video. You may click the Unit 5 video support link to watch introduction videos if you need more support. Warm up, grapes per minute. If you eat 5 grapes per minute for 8 minutes, how many grapes will you eat? If you hear 9 songs per day for 3 days, how many new songs will you hear? And if you run 15 laps per practice, how many practices will it take you to run 30 laps? Please pause here and attempt your warm-up before moving on. One strategy you may have tried to solve your bell work is to make a table. So if you eat 5 grapes per 1 minute, then for 8 minutes, how many will you eat? You can use your constant of proportionality here, that we're multiplying the minutes by 8, so we multiply the grapes by 8, and 5 times 8 equals 40. So in 8 minutes, you will have eaten 40 grapes. If you hear 9 songs per 1 day for 3 days, how many new songs will you hear? So each day you're listening to 9 new songs. So 9 times 3 equals 27 new songs. If you run 15 laps per practice, how many practices will it take you to run 30 laps? This might be a good place to have a table or an equation. If you're using a table and you do 15 laps per 1 practice, then how many practices would it take you to run 30 laps? So 15 times a number equals 30. So 30 divided by 15 equals 2. So that means you're multiplying your numbers by 2. And 1 times 2 is equal to 2. So it would take 2 practices. Another way to think about this would be to skip count by 15 until you get to 30, which would take you 2 times. Water level in the aquarium. A large aquarium should contain 10,000 liters of water when it is filled correctly. It will overflow if it gets up to 12,000 liters. The fish will get sick if it gets down to 4,000 liters. The aquarium has an automatic system to help keep the correct water level. If the water level is too low, a faucet fills it. If the water level is too high, a drain opens. One day, the system stops working correctly. The faucet starts to fill the aquarium at a rate of 30 liters per minute, and the drain opens at the same time, draining the water at a rate of 20 liters per minute. Is the water level rising or falling? How do you know? Please take a minute to attempt this task before moving on. Is the water level rising or falling, and how do you know? So the faucet is filling up the aquarium at a rate of 30 liters per minute. So that's positive 30. The drain opens, draining the water at a rate of 20 liters per minute. Okay, so we have positive 30, and we are adding negative 20, all within the same minute. 30 plus negative 20 is positive 10. So that means the water level is rising, and it's rising 10 liters per minute. How long will it take until the tank starts overflowing or the fish gets sick? Because we are increasing, we're looking at the overflow amount. So we're currently at 10,000 liters, and we don't want it to overflow. It overflows at 12,000. So 12,000 minus 10,000 means that we have 2,000 liters until overflow. Okay, so if we have 2,000 liters before we overflow, and we are increasing by 10 liters per minute, that means we have 2,000 divided by 10 minutes before overflow. So 2,000 divided by 10 equals 200. So we have 200 minutes until the tank overflows. If you wanted to convert that to hours, you could do 200 divided by 60. 200 divided by 60 would give you the number of hours until the tank overflows. A different aquarium should contain 15,000 liters of water when filled correctly. It will overflow if it gets to 17,600 liters. One day there is an accident and the tank cracks in 4 places. Water flows out of each crack at a rate of 1/2 liter per hour. An emergency pump can refill the tank at a rate of 2 liters per minute. How many minutes must the pump run to replace the water lost each hour? So looking at this problem, we have 4 different cracks. So we have a crack here, and a crack here, and a crack here, and a crack here. And each one of them is losing water at a rate of 1/2 liter. So each of them. That means the total amount that is leaking out is 1/2 times 4. So 4 times 1/2 equals 2. So we are losing 2 liters per hour, which can be shown as a negative change. So -2 liters per hour. Now, the emergency pump can refill the tank at a rate of 2 liters per minute. So how many minutes must the pump run to replace the water? So 2 liters per minute. So how long will it take for the pump to counteract the -2 liters? It will only take 1 minute. It will only take 1 minute because 1 minute replaces 2 liters, and in the whole hour, you're only losing 2 liters. So pump must run 1 minute per hour. Up and down with the Picards. Challenger Deep is the deepest known point in the ocean at 35,814 feet below sea level. In 1960, Jacques Piccard and Don Walsh rowed down in the Trieste and became the first people to visit the Challenger Deep. If sea level is represented by 0 feet, explain how you can represent the depth of a submarine descending from sea level to the bottom of Challenger Deep. Okay, so if we're talking about feet below sea level, how can I show below sea level? Another word that helps you understand is descending. So what we could do is use negative numbers. And if we are 35,814 feet below sea level, Challenger Deep can be shown as negative 35,814 feet. Trieste descent was a change in depth of -3 feet per second. We can use the relationship y equals -3 times x to model this, where y is the depth in feet and x is the time in seconds. Using this model, how much time would the Trieste take to reach the bottom? So we know that it's negative 35,814 feet. Y is representing the depth in feet. So we can rewrite this equation as 35,814 negative equals negative 3x. To solve this relationship, we can use a fact-family triangle or our knowledge of how to solve equations. So if I know that negative 3x times a number, negative 3 times x equals negative 35,814 feet, then negative 35,814 feet divided by negative 3 is going to equal x. So x equals 11,938 seconds. Lesson synthesis. Recall that we can represent speed with direction, called velocity, using sign numbers. We can do this with vertical movement, in fact, with any rate. The convention is that up is the positive direction and down is the negative direction.